Certainly do. Good morning, Year 10s. Nice to see you all. Jack. Oh, man. Jack, were you trying to get in first again and you just didn't make it? Yeah, well done, Callista, for getting in first. Good job. I have been not even second, lol. Callista just absolutely slammed you. That's amazing. I love it. Absolutely love it. Jack, don't worry.
Certainly do. Good morning, Year 10s.
That's
nice
really
to see
funny.
you all.
It's proper cracked me up, that has. Love it. Right, I'll close that down, save my bandwidth. Right, I'll share my screen. Let's crack on with chemical tests part 2. And I'm going to change my camera. Change my camera over to that guy. Woo! There we go. Check out my t-shirt. Yeah, the flux capacitor. It's my favorite movie of all time. Back to the Future. Back to the Future. Right, let's crack on, folks. Okay, so we've just done a review. It's just a tradition now to try and get in first. Yes, I realize this. Pish. Right, I'll minimize that. Right, guys, chemical tests. But oh, I forgot my learning objectives. That's irritating. Hang on one sec. Edit. Let's take those. Right. So go. Okay. I'll switch my tablet into tablet mode. And I found a new tip for my pen. Whoop, whoop. Yeah. Yeah. So, chemical test lesson 2, cations part 2. So, just to do a quick reminder. So far we have done part 1 was flame tests. So we looked at flame tests and we realized that there are 6 we need to know. Lithium 1+, sodium 1+, potassium 1+, calcium 2+, copper 2+, and barium 2+. It's also nice to add on strontium 2+. I do like those 7. And we've got to learn those colors. So we've got red, yellow, lilac, orange, red. For calcium copper is blue, green. And then we have barium, which is green, and strontium, which is red. So we've just got to learn those. Now what we realize is there are other ions of high importance that we need to also test for that don't flag up on a flame test. So important ions, you now get 6. Okay, so by the way, it's actually not 6, it's actually 5, annoyingly, but I know it's really stupid. So ions that give no, look at the underline, no flame test result, no flame color, include aluminium 3+, magnesium 2+, iron 2+, iron 3+, and technically those are the only 4. By the way, there are others that don't do it, but these are the ones that come up regularly in the exams. Now, what's really strange at this point? So these guys genuinely give no flame color. This is where I've suddenly realized I've got something awkward here, because now I need to go / There are 2 other ions in here, which is we need to do calcium and we need to do copper 2+. Now, this is strange, because these guys do give flame colors. Do give flame test, but they link them together. They link it with this second set of tests, which is called a precipitate test. Now, I know this word is horrible. Yeah, this is actually one of the 5 signs of a chemical reaction. So the first thing I need to do is I just need to do a quick note on the word precipitate. Precipitate. Now, can I just point out that geography stole this from me? It's really upsetting that geography pinched it. But there is a similarity between the geography definition and the chemistry definition. A precipitate in chemistry, a precipitate is when a solid appears, in a solution. Now, people often go, I don't get it. What does that actually mean? Let me show you. This is what a precipitate looks like. Precipitate test images. It's when a solid literally appears. There. Oh, I'm going to need this picture later. So I hope everyone can see that. I wonder if I can find there. There's even better pictures. Look at those precipitates. Aren't they lovely? Just look at all of those precipitates. Oh, they're gross. So what's happening is you started off with, let's draw a diagram for that definition there. Let's put this in a red bubble because we need this. When a solid appears in a solution. So what does this mean? It means this. If you had a test tube containing a colorless solution, yeah? So we'll put colorless solution. A colorless solution. If I then add X, yeah, what will now happen is I'm going to form a precipitate. And that precipitate will literally look like gunk. Yeah, I'm going to go for gray. Yeah, it will go murky. It'll become cloudy. I hate the word cloudy. You're taught cloudy for the carbon dioxide test, and it absolutely drives me bonkers. Can you make it a little side note? This is a nota bene. Nota bene. Test for CO2, for carbon dioxide. You did this in year 7. You do it in chemistry, and you do it in biology. And the test is to have your test tube, and you've got lime water. Yeah, this is lime water. By the way, formula for lime water is calcium hydroxide, Ca brackets OH2. I hope everyone's able to do that from the words. Just to remind us how that's built. Calcium is a 2+ ion. It comes from the periodic table. We know this. Yeah, we find calcium. Calcium is in group 2. There's calcium. We know all group 2s are +2. We know our OH- ion, which is 1-. Cross and down, it's a complex ion. So I only need 1 calcium, but I don't need to show it. But I have to put the OH into brackets. So there's calcium hydroxide. And what you now do is you now bubble CO2 gas into the liquid, into the solution. So the bullet point here is bubble. And by the way, this mark is commonly lost at GCSE. Very common. Like people say, test for lime water. Test for carbon dioxide, 2 marks, and they go lime water, cloudy, lose your mark. You get 1 mark for cloudy as the observation, but the first mark you lose. Bubble gas through lime water. You can't just say lime water. It's really common. Teachers make that mistake too. Bubble through lime water. Observation. Obs. White precipitate. I'm going to write PPT and then underneath put precipitate. You do need to be able to spell it, by the way. White precipitate. Or, and I hate it, you're allowed to say it turns cloudy or milky. I despise these. Like, just, it's just such terrible chemistry. It's like, really? Really? If you want to see the equation for what's happening with that, the calcium hydroxide is an aqueous solution. It reacts with the CO2 to form limestone, which is a solid and insoluble. Yeah, and we also get water as a byproduct, but you don't see that. Yeah, so there's the equation. The carbon dioxide reacts to form solid limestone, and there's your white solid. White solid, everyone knows white solid. Everyone knows limestone. Yeah, it's always good to look at it anyway. That should be fixed now, guys. I know. I'm so sorry, guys. What happens is, let me know if that's okay. Guys, is that any better? I can see that everyone's messaging me on the Hangout. Sounds like Alvin in an old stereo underwater. Yeah. Is it fixed? Somebody post on the chat to let me know if it's fixed. Pretty much. Pretty much? Oh, that's not great, is it? I feel like the problem is I've bought cheap electronics. Still okay? Oh, I'm really worried that I've fiddled with cables now. And it's just, I've got a USB splitter, and the USB splitter is really cheap from Lazada. Don't ever buy cheap stuff. And so the connectors aren't like, because if you want to buy good electronics, LOL, the delay. I know there's a big delay. I get it. Oh, I've suddenly realized that you guys are all seeing my screen. Lol. There we go. Sorry about the delay, folks. There's not really much I can do about that, unfortunately. It's just part and parcel. Right. So this is the idea of the precipitate test. You know, we're going to see these solids appear in solution. So what we now need to do is, I now need to show you these 6. So you're going to get given 6, there are 6 white solids here. Now, the first thing that you're going to do, if you ever get given an unknown solid, so here are 6 unknown solids. Now, the first thing you're going to do with these solids, before you do any precipitate tests, is you're going to do a flame test. That's the first thing you'll do. Step 1, complete flame test. It's the first thing you do. Now, in these 6 solids, we see 4 complete a flame test, observations. 4 give no flame color, no flame test. 1 gives blue-green, and 1 gives me orange-red. So at this point, we could technically remove 2 of them from the system. Yeah, we could, because we've now identified the cation in 2 of them. Now, the first thing to realize here is, I'd like to also mention the solids. Do you realize that it appears that 3 of them are genuinely white? Actually, 4 of them are white, and 2 of them appear to have a color. So on the chat, please, can someone tell me what the color of these 2 here have got a color? What does it tell me is, in terms of the cation, what does it tell me is in those compounds? Because of the solid having a color. What does that tell me about this cation?
Right. So at this point, we've got four give no flame test, one gives blue-green. We can now identify that one, of course, the blue-green color. Just going to go for that. So that one there is going to have been copper 2+, and then the orange-red, of course, is going to be calcium 2+. Yeah, transition metal cation. Well done, Julius. Transition. I like it. It's not how you spell it, Julius, but it's amazing. Yeah, well done, Lauren. They contain transition metals. Now, at this point, 4 didn't give it, but 2 did. So at that point, what I'm now going to do is we're now going to continue the process. We're going to continue the process with the other 4. So the other 4, we're going to continue. So I'm now going to tell you which ones did it. So this one gave me the blue-green. This one gave me the blue-green flame. So this one contains copper 2. Now what's interesting is it's white. This is because it's anhydrous. And I'm going to come back to that. I know that's the test for water, and I'll show you that today. This one over here gave me the orange-red. This one gave me orange-red. So this one I now know is calcium 2+. I now have 4 other solids that I still don't know the cations in. So now what I'm going to do is I'm going to do my new test, my what's called the sodium hydroxide. Sodium hydroxide. Guys, can you write the formula for that underneath there? Sodium hydroxide precipitate test. Okay, so here's your method. So your formula is going to go here, guys, for sodium hydroxide. Okay, method. So step number 1. Step 1. Take a small sample. By the way, people often then say, what's a small sample? This is, chemistry is cooking, folks. It's literally cooking. Cooking is chemistry. And in fact, that's where chemistry started. You know, when we were in caves as cavemen, the first chemistry that we ever did was cooking. You know, we realized that if you could argue that we created fire, that's also chemistry as well. But cooking was the first real kind of practiced chemistry that we were doing. And it's because when you heat stuff up, they change. And in cooking, we often say, take a pinch. And that's actually a really good measure. Now, I'm just going to show you, take a small sample of unknown solid, and add to deionized or distilled, whichever one you prefer, water. By the way, this is actually otherwise known as pure water, but you're not allowed to use the word pure. I know that sounds crazy. Students often say why. It's because it tells them that you don't have an understanding of how this was made. Yeah. The deionized water means you have removed ions. This word here, deionized, literally means ions have been removed. No ions. Deionized. No ions. Yeah. Ions have been removed. And the way that we remove it is by distilling it. So you're allowed to say distilled water alternatively. Yeah, but you're not allowed to just say pure water. You have to use either one of those 2 words. So I want to show you what a small sample actually looks like. Small sample on spatula. I'm going to show you what that looks like. This is why this is really hard to do, because we'd be doing this in class, because I need to show you what this looks like. Yeah, it's not a good picture, is it? I really need someone who's done this. You see, that's not a small sample. That is a massive sample, guys. Oh my God, that's about 10 times too big. Yeah, you need the tiniest little bit. Oh, do I genuinely have to draw this? It looks like that. That's literally what a small sample looks like. That's the worst arrow I've ever drawn. Like, you literally need a tiny amount, small sample. And we're going to add this to water. So what does this now look like? We're adding this to deionized water, distilled water. Distilled water. Can I just point out, the exact opposite of deionized water is mineral water. Mineral water has all the ions in it. You buy mineral water from the shop because it's good for you. We need ions in our diet. You don't want to drink distilled water. It's actually like, it won't kill you. Like, it tastes a bit odd. It doesn't really taste of anything, actually. But the lack of flavor is the strange thing about it. But the other key thing is that you can drink a little bit and it does you no harm, but if you drink a lot of it, you'll dilute your blood. You'll actually reduce the ions. You need the ions in your blood because it's for your heart and your nervous system. So we're going to add this tiny little sample to water. And step 2, shake until dissolved. Shake until dissolved. So we need the solid to disappear into the solution. Yeah. So we shake it. Give it a shake, yeah, until the solid has vanished. Right now, step 3, add a few. People don't like a few. Yes, add 3 drops of sodium hydroxide solution. Sodium hydroxide solution. Brackets NaOH. Right, and what you're going to see is this. Right, so we've got 4. So let's do magnesium. Magnesium precipitate. There you go, and that's what you see. You add a few drops of sodium hydroxide, and that's what you get. You get a white precipitate for magnesium 2+. So add 3 drops of sodium hydroxide. Step 4, record observations. Record observation. That's observations in French. Just ask Lauren. Record observations. So what we're going to see, magnesium 2+ starts off colorless. Yeah, this is where I need to try and desperately do some clever things here. Starts off as a colorless solution. Colorless solution, but then becomes a literal, like, what I should actually do there is realize it needs to be on a black background. What will happen is you will form a white precipitate. You'll form a white precipitate. Just to show you what's happening, the magnesium 2+ is reacting with 2 hydroxide ions to form insoluble magnesium hydroxide. That's what's happening. You form a white solid. That there is a white solid. And it's nice actually for me. If you're making notes, by the way, on a digital tablet, God, do what I'm doing. You know, these pictures are super handy. Like, super handy. Come on, come on, come on, come on, computer. Come on. Come on. There we go. Just a big picture, obviously. Shrink that down. Oh, there we go. There you go. Form a white precipitate. Okay. Next. The next one we had was aluminium 3+. Now, aluminium 3+ started life as a colorless solution. I know this isn't really working out very well, guys. I'm sorry for this. Colorless solution, colorless sol, and we add sodium hydroxide, and it forms a white precipitate. Oh dear. That's a problem. Let's have a look at the equation. So this is aluminium 3 plus reacts with 3 OH minuses, and we're going to form aluminium hydroxide, which is a white solid. White solid. Let's have a look at what that looks like. Now, guys, this one's really clever because there's a problem, isn't there? There we go. There's the picture. Yoink. Copy. There we go. So, can anyone now tell me what the problem is? What's the issue we now have? Remember, we didn't know what these solids were. They were unlabeled. So, I can now tell you that this one formed a white PPT. And this one formed a white PPT. What's the problem? We know that they're going to either be magnesium 2 plus or aluminium 3 plus. That's a problem. Which one's which? So now we do something really clever. What we now do, if you ever have 2 white precipitates, you add excess sodium hydroxide. Add more. Both results look similar. Thank you, Zaina. Add the word excess, by the way. The word excess literally means too much. It means loads. It means more, like so much. It means there's so much more than everything else. Excess means that there's so much, there's huge amounts not being used. Add excess sodium hydroxide. Add loads. And what's really cool is, here's what happens. One of them does absolutely nothing. One of them doesn't change. One of them doesn't change, but the other, this is where, oh, can I, God, a YouTube on a YouTube on a, it's a really bad idea, this. It's going to be really horrible quality, this, I'm sure. Aluminium, precipitate test.
केमिस्ट्री एंड जेल को और साथ
No, he's doing something completely different. I hate you. He doesn't need to. Oh, hate people. Can you guys all see this? So, colorless solution. Add a small amount of sodium hydroxide. White precipitate. But look what happens when he adds excess. And do you see what I mean by excess? Right, give it a shake, dude. Give it a shake. Okay, he's actually going to stir it. It redissolves. It actually vanishes again. So it redissolves on excess, whereas magnesium doesn't. So this one, so it'll just vanish again. In excess sodium hydroxide, it'll just redissolve. I'm trying to find a good picture of that. It's really annoying. It will just vanish again. You get a white solution and then it disappears. I want the same picture but colorless. Oh, it doesn't matter. Redissolves. Redissolves. Vanish on excess. So it just becomes a colorless solution again. So we've done the white ones. We've done 2 of them. Right. So this one formed a white precipitate and no change on excess. So that now becomes Mg2+. But this one gave a white precipitate and redissolved on excess. That's aluminium 3+. You'll be doing all of this in school when we get back. We're meant to be doing it today. Oh, it makes me so upset. What's the point in chemistry? Right, 2 more to go. Who are these guys? Right, so I'm going to take a small sample of these guys. So next observations. So there we go. So Fe2+ is a pale green solution. Now, at this point, people often go, oh, hang on a minute, why do I need to do the precipitate test? I will explain. And this is a pale yellow solution. Right. Now, guys, these let me show you what these look like. So, iron 2 solution. Pale green solution. There we go, there's a good picture. Screen snip, cut, that guy. Hello, edit, copy. Gives a pale green solution. Paste, there we go. So you can see it does have a color, but it's very pale. Now, if you add more on it, it will become darker. Yeah, but of course, you might just be given a solution. Whereas iron 3 solution is yellow. Check it out, and it's a pale yellow. There we go. So the question I now have to you guys is, why do we need to do a precipitate test? I'm hoping that you guys will usually give the same answer, be like, oh, you don't need to. Yeah. The reason being is you could argue that they could actually be quite similar. And the next thing is, by the way, that iron 2 will become iron 3 over time. So the green one will turn yellow if left open to the air. So that's something to bear in mind. But what we now need to do is actually guarantee this. So we're going to add a small amount of sodium hydroxide. So now, step 1, I don't like the fact that it's so close to that other writing. Overlaps. There we go. I'm just going to move that all over a bit. So we're going to add a small amount of sodium hydroxide. 3 drops. Add 3 drops of NaOH. And what do I see from iron 2+? Iron 2 precipitate. There we go. I'll do it. And there you go. So it turns green. I get a green gelatinous. It's cool, isn't it? Gelatinous. A green precipitate. Now, what I also want to show you is that if you leave that over time, look what happens at the surface. It turns brown at the top. This is because it's oxidizing in the air and turning into iron 3+. But you get a green precipitate. So you'll form, I'm going to add the picture. Well, these pictures are quite nice, to be fair. If you have a tablet, God, please do the same. You'll form a green, I'm going to shrink that down a bit. You'll form a green precipitate. Observation. Green PPT, which turns brown on standing. There you go. But it turns green. Turns green and then turns brown on standing. Right, so what happens with iron 3? Let's add 3 drops of sodium hydroxide, of NaOH. What am I going to see? And you see a very different color. A very different color. Boom. You're done. It turns brown. Really brown. A proper, there we go, that's it. And that's a perfect image, actually, because they had a nice dilute version, which was, if you notice, that image is brilliant. Because what's happened is the solution was a very, 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 very pale yellow. It actually matches mine really well. Go away, you stupid keyboard. Oh, this is a massive image. It's going to be interesting. So, oh, not as slow as I thought it would be. Not as quick as amazing. So you form a brown precipitate. Observation. Obs. Brown PPT. Brown precipitate. And that's it. Looks orange. Yeah, okay, it does look orange, but it's brown. Like, it's only orange as it goes in. Look what happens when you leave it standing a while. It's very dark. Yeah, it's a brown precipitate. Yellow solution, brown precipitate. Yeah, I agree, it does look a little bit orange. They'd probably accept orange. Probably. Brown precipitate. And that's it. That there is the sodium hydroxide test. However, I now need to include 2 others. Do you remember those 2 that gave a flame test? Confirm calcium and Cu2+. So turns out that even though these guys give flame tests, oh, I've suddenly realized my lesson's coming to an end. I'm just going to be really quick. To confirm these guys, I'm going to do a precipitate test as well. So add my calcium 2+ sample. Add my calcium 2+ sample to deionized water. Yeah, add then sodium hydroxide. Once it's dissolved, add NaOH, and we will form a white precipitate. A white PPT. White PPT. Yeah, so it's a confirmation test. Just to show you this, I'm going to do calcium precipitate. There you go, you form a white precipitate. So that confirms that it was calcium. We saw the orange-red flame and a white precipitate. The copper 2+, so we've got our copper 2 sample. We add that to water, and the water will turn blue. We end up with a pale blue solution. Pale blue solution. We then add a small amount of sodium hydroxide, 3 drops. And what I am going to see is a dark blue gelatinous precipitate. Let me show you. So this is now copper precipitate. We're done. There we go. There you go. Dark blue precipitate. Did I write that one down? Blue PPT. Just to show you the equations for all of them. So calcium 2+ will react with 2 hydroxide ions to form calcium hydroxide, white solid. Copper 2+ will react with 2 OH- to form copper 2 hydroxide, which is a blue solid. Then we have aluminium 3+ reacts with 3 OH- to form aluminium hydroxide. If you really want to be super smart, you can then it then reacts with an extra one to form aluminium tetrahydroxide, which is a 1- charge, and that's the redissolved bit. That's the solid, and that's the aqueous, that's the redissolving reason. But you don't need that for GCSE, that's A level. And then we have Fe2 plus reacts with 2 OH minuses to form iron 2 hydroxide, which is green, solid, and then iron 3 plus reacts with 3. I hope you're realizing the pattern. The charge tells you the number of OHs that are going to become attached. And that's a brown one. And there are 5. Which one am I missing? Magnesium, sorry. Mg2 plus. Plus, surprise, surprise, 2 OH minuses, forming MgOH2. It's white solid. And we can now color code all these and say white. Not good enough. And I need to be as thick as possible. White precipitate. White precipitate. White precipitate. Redissolved on excess. Yeah, redissolved on excess. Blue precipitate. Brown orange precipitate. I prefer that they iron 3 brown precipitate and iron 2 a green precipitate, which will turn brown on standing at the surface. And we're done. That's it. It's the end of the lesson, folks. Let's go back to my learning objectives. So, number 1, NaOH precipitate test. Observations and write equations. We're done for today. I'm sorry that we overran by 3 minutes. I'm very sorry. And it would have been absolutely spot perfect if we hadn't done the recap. Let's bring it back to this guy. Right, guys, I will leave you be. I hope that all made sense. That now is the end of cations. There is actually one cation we need to mention, which is the ammonium ion. Because it's the only complex cation we have. And the great thing is, it's the same sodium hydroxide test. I'll actually do that in the complex ion bit. I'm going to do the test for the complexes, for the complex ions, in a separate lesson, and that one will appear there. But the great thing is, it's actually the same test. You add sodium hydroxide to it, and it'll turn it into ammonia gas, and then you have to test for the ammonia gas. I'll do it separately because it is slightly different, because it involves a gas test as well. So anyway, guys, I hope you found it useful. I'm sure you've all gone by now, and I will see you all very soon. See you next lesson, guys. See you tomorrow.